If you have ever been inquisitive about the fundamental equation that dictate the behavior of particles at the most minuscule scales, then it is this. Yes, I am talking about Schrodinger equation, a cornerstone of quantum physics. But before going to dive headfirst into this complex mathematical equation or obscure theories, I'm going to guide you through the learning process, breaking it down step by step. You might be wondering, where do you begin with sometimes this formidable Schrodinger equation? I will discuss the learning process, what you need to do to grasp this concept, and the essential mathematics that is required. But here is the best part. I will introduce you to a book that assumes no prior knowledge of advanced mathematics. Yes, it provides you with a complete understanding of the subject. This book is your quantum gateway, your key to unlocking the mysteries of Schrodinger's equation. In this video, you are about to demystify a complex concept and make it super easy. My name is Shaunak and you are watching this video on my channel Physics for Students. Welcome on this video, how to understand Schrodinger equation, the best book, the best resources and the best study guide. So before we go ahead and understand the book and explore it, first I would like to tell you just in brief what is Schrodinger equation all about. Here is a very basic definition that the Schrodinger equation is basically a linear partial differential equation that governs the wave function of a quantum mechanical system. And as we all know, and I will explore, that wave function is basically the pivotal force around which the entire quantum mechanics revolves around. So its discovery is definitely a significant landmark in the development of quantum mechanics. So the Schrodinger equation, we tell it, is a fundamental equation of quantum mechanics that describes how the quantum state of a physical system changes over time. It was formulated by the Austrian physicist Erwin Schrödinger around 1926. Now, what do I mean by this definition? I would like to make it a little bit easy. First is that it describes the quantum state of a physical system. Now what do I mean by that is this. It encompasses all the information, all the vital statistics needed to describe the system's behavior. It includes details about position, momentum, energy, and so on. The second thing is that it also shows how the quantum state changes over time, which means that it describes how the quantum state of a physical system changes over time by providing a kind of a mathematical relationship between the state of the system at one time and the state which is evolved in a later phase of time. So this is what we mean by the equation, that it describes a quantum state of a physical system. It includes various position, momentum and other important factors, and how the quantum state changes from this time to that time. Now if we go ahead and we see, fundamentally you will see that the entire concept of Schrodinger equation is very simple and almost something which is very classical. Kinetic energy plus potential energy would be equal to total energy, and it obtains information about the behavior of an electron which is bound to a nucleus. Now if you see this rather reduced form of Schrodinger equation, then what we get is a psi, or if once we square it to get a probability density, we get it psi square. So what it tells is that with these we get actually the quantum numbers and the shapes and orientations of orbital that characterizes electrons in an atom or molecule. That means the Schrodinger equation actually helps us to get some quantum numbers which helps to shape the orientations, and as we know that the electrons in an atom or molecule will help us to understand things better. But apart from this understanding, there is something which is called this, which is called a wave function. I've discussed it earlier in my videos on quantum mechanics. What is a wave function? But just to understand that by solving the wave function, we can get a lot of information which helps us to understand, predict or do a kind of an analysis of a quantum system. The question is that what are those information? I mean to say, what are we actually talking about this information? Let us look into what are those information, why it is important in the next part of the video. So if I take the Schrodinger equation, the first thing is that it helps to understand the energy level. That means it is used to find the energy levels of different quantum system. Wave function, which is a vital information, it tells solving the Schrodinger equation, we get the probability amplitude. So we can probably tell that the electron or the subatomic particle is located around here, or maybe probably located around there. The quantum states actually are the solutions to the Schrodinger equation, correspond to the quantized states of the system. Very importantly, it is something which is called an observables. That means from the wave function we can compute various observables such as position, momentum, angular momentum, whatever will be required to predict and understand that quantum system. Also the probability distribution, because once we analyze the wave function we can actually determine the probability distribution. As we know that from classical to quantum, as we move, there is nothing definite. All we get is a kind of a distribution. So these are actually what I was talking about, some of the vital and most fundamental and important information that we get once we analyze, or once we find out what this Schrodinger equation is all about. Now this is something very central. Conceptually we can say that Schrodinger equation is the quantum counterpart of Newton's second law in classical mechanics. Now what do I mean by quantum counterpart? Now if I get a kind of an equation, or you can say a line, a particle which is moving in this way, then obviously in Newtonian mechanics we get what is called a path is given in the physical system, where it will go, where it will land to, something like that. And if I get a kind of a wave, or I would say probability distribution over here, then the psi, the wave function, actually tells that the evolution over a time of wave function, the quantum mechanical characterization of an isolated physical system. So you can see that this is also predicting something, where the path or where the particle would go. Here also it is telling something that through time what the quantum mechanical system will evolve into. So what I'm trying to tell is this, that Schrodinger equation is conceptually the quantum counterpart of Newton's second law in classical mechanics, and it is valid, and it is a very insightful comparison, or I would say an insightful discussion. Now what do I mean by quantum mechanics compared with classical mechanics, how it can be compared, and how things go. So let us look into the next part of the video what I am trying to tell. So first thing that we need to understand is that both the equations provide mathematical predictions. Both Newton's second law and the Schrodinger equation provide mathematical frameworks for making predictions about the behavior of physical systems. Say for example, in classical mechanics, Newton's second law relates the forces acting on a particle to its acceleration and velocity. Similarly, Schrodinger equation describes the evolution of quantum system wave function in terms of its energy and the Hamiltonian operator. So in both the cases you can see that given the initial conditions, you can make a prediction about the future state of the system, whether it is Newtonian or a Schrodinger equation. The next thing which is very striking is both of them determines a kind of a predictive nature. So both equations offer deterministic prediction. Newton's second law, when given the initial conditions of a classical system, can predict the future trajectory of a particle. Likewise, the Schrodinger equation, when provided with an initial quantum state of a system, predicts how the wave function will slowly evolve over time, offering insights into the quantum behavior of particles. Also, both of these systems talks of something which is called an isolated physical system. Now what do I mean by that is that both equations apply actually to isolated physical system. Newton's second law is used to describe the motion of classical object in the absence of external forces. Similarly, the Schrodinger equation characterizes the quantum mechanical behavior of an isolated system. Typically, I mean to say without any influences. So this isolation is essential for understanding the system's intrinsic behavior. Also, there is something which is called a general applicability. Newton's second law is a very fundamental principle in classical mechanics and is applicable to a wide range of macroscopic, I would say, physical system. Similarly, Schrodinger equation is a fundamental concept in quantum mechanics and applies to diverse quantum systems from individual particles to complex molecules and beyond. So this is something very important. I am not saying that Schrodinger's wave equation is classical in nature, but I would say overall it predicts something which is more of F equals to ma, that is I mean to say the Newton's second law. So having understood what is Schrodinger equation, how it can be called as a counterpart I would say, quantum mechanical counterpart of the classical F equals to ma, now it is the time that we should look into what is the importance. I mean to say, every equation has got an importance. So what is, why it is important, why Schrodinger equation is considered to be important. Number one, remember that the Schrodinger equation forms the foundations of quantum mechanics. So it provides a very fundamental framework which we have just seen to understand the quantum world. Second, it enables physicists and scientists to predict the behavior of particles in the quantum realm. By solving Schrodinger equation, you can determine the probability distribution of finding particles in various states and position. And this is crucial for understanding the fundamental nature of matter and energy. Energy level and spectra, the Schrodinger equation, I would say, is instrumental in determining that allowed energy of a quantum system, such as atoms and molecules. So it explains the quantization of energy, which is fundamental concept in quantum physics, and it underpins the understanding of atomic and molecular spectra. Chemistry and material science, yes, this equation is central to the field of quantum chemistry because it allows scientists to study the behavior of atoms and molecules, predict chemical reactions, and understand the electronic structure of materials. This knowledge is crucial for advances in material science, drug discovery, and as well as chemical engineering. Not only for that, quantum computing in the emerging field of quantum information and quantum computing, this equation plays a pivotal role. Quantum computers uses the principles of quantum mechanics, and the Schrodinger equation helps to describe the quantum states and operations in the revolutionary devices. Technological advancement, this equation also helps to provide practical applications in a wide range of technological advancements, including semiconductors, laser, nuclear reactions, magnetic resonance image, which we popularly called as MRI, and various other things. Cosmology and astrophysics, yes, quantum mechanics driven by Schrodinger equation plays a role in our understanding of the behavior of matter and energy in the universe. It is the study of behavior of particles in extreme conditions such as inside the star or black holes. So having laid this one, I think that the objective, the importance, and why Schrodinger equation is the fundamental equation, things are clear. Now comes the question, everything set and good, fine. What kind of mathematics do you need to learn, and what is the mathematical prerequisites that you need to learn? Coming up in the next part of the video, what mathematics do you need to learn? Now first, obviously the mathematics would be calculus, because understanding derivatives is crucial, and Schrodinger equation itself involves derivatives of wave function with respect to position and time. So number one would be calculus, both integral and differential. Second would be linear algebra, because understanding matrices, vectors, and vector spaces is fundamental, as quantum states are often represented using vectors in complex spaces. You also need to understand what is an eigenvalue and eigenvector, which plays a significant role in solving the Schrodinger equation. Next class, complex numbers, because quantum mechanics, as we have seen, frequently employs complex numbers, so you should have a strong understanding of quantum numbers. Complex numbers. Obviously, partial differential equations, you need to have a strong understanding of PDEs to work with those equations. The next thing which comes would be the probability. Obviously, the entire quantum mechanics revolves around probability. So you need to have an understanding of probability and statistics, because concepts such as expectation values and probabilities are very central to quantum mechanics. Function spaces, this is also very important, and Dirac notation, the specialized notation, including Fourier analysis, which would be important. I have already made a video on Heisenberg's uncertainty principle and Fourier analysis. All of this, how they are related. Now you might be wondering, how on earth shall I learn all those things just to understand the Schrodinger equation? Well, I would say there is no shortcut to success, but yes, you can make a kind of an understanding that what are the things that are must have. I mean to say, you can understand Schrodinger equation more or less with those things, which is a must have, but even if you don't have those things, you won't be able to understand. So first would be definitely calculus. I have explained the reason, because it includes derivatives, integrals, and differential equations. You need to understand linear algebra, vectors, matrices, eigenvalues, etc., and definitely complex numbers. So you can say that we have actually found out a shortcut way out, although all those prerequisites are essential to get a very, very solid understanding of the equation. So calculus, linear algebra, complex number, these are the trio, these are the three things which is a must-have, without which you won't be able to understand anything. Now, what I would like to show you is that this playlist of mine, quantum mechanics, around 20 videos, covers up almost, I won't say everything, almost all the videos, all the mathematics that is required. Here you can see I have started with complex numbers, complex plane, imaginary number, then I have come to complex conjugate, further examples, 1, 2, 3, and so on. So all this 5, 6, 7, so all this you can find it in my playlist of physics for students in quantum mechanics, and you can see these are quite a lot of videos. Step by step I have taught how to understand the mathematics of quantum mechanics. Not only that, these videos, as you can see, what is quantum mechanics, history of quantum physics, what is a classical system, what is I would say normalization, wave packet, all these are also there to give you a complete understanding of quantum physics as well as the mathematics that are required to understand quantum physics. So by this time you have understood Schrodinger equation, its importance, its classical counterpart, what mathematics you need to learn, why it is important. Now it is the come that you have been now you have come to the time that you have been waiting for, which is called which is the best book to learn. And I would straight away recommend Daniel A. Fleisch, Student's Guide to Schrodinger Equation, and I'm going to show you and prove you why I consider this is the best book till date which is available. First, let me show you the Amazon rating. This is around about 80%. I won't be quite happy even it goes beyond 95%. And this is a Cambridge University book. It is not much, 234 pages. That's it. These are some of the great reviews which you can see from United States. Another great book by Daniel Fleisch, terrific, great starting, and here it says great ways to learn from 0 to 100, helpful for undergraduates, exceptionally well written. And from India we have got a similar kind of a understanding. Here it is must read introductory book, exceptionally well written, the book gets to the point, a physical introduction. So overall I'm just trying to make my point that everybody says this book is one of the best books. Look, let us go back to the content of the book, the arrangement and the content of the book coming up in the next part of the video. So the book has been arranged in this way. First is vectors and functions, obviously to give you a strong understanding of what are vectors and functions. Then it will move into operators and eigenfunctions. Third would be the Schrodinger equation. Fourth would be solving the Schrodinger equation. And fifth would be solutions for specific potentials. Very simple. 5 essential ways, and these are the key to unlock the mysteries of Schrodinger equation. Okay, so here you can see this is the table of contents, just 216 pages, but it is these 216 pages are a gem. It is a treasure, and I'm just going to show you why I'm talking those. So first you see these are the pages which I have taken some screenshots. Vector basics, so it covers up vectors, abstract vectors, notations, then Kronecker delta, finding components using inner product, label, inner product shows like this, that, etc. So it covers up first with the vector part, and if you are wondering that you really need to know more about the vector, here is another book of Daniel Fleisch which is called Student's Guide to Vector and Tensors. It is an absolutely great masterpiece book. You can go ahead and check it. Then the book talks about operators and eigenvalues and eigenfunctions, Dirac notation, projection operators, Hermitian operators, expectation values, and you see how these matrices etc. are being done. Now, if you're wondering that this book and you are a YouTube learner, you want to learn through videos, here are my quick recommendations of my own video. Here you can see I've made 1, 2, 3. These are the videos just made on the bra and the cat notation, expanding more on the bra part, then on the cat part, the Dirac notation, Schrodinger's cat, quantum set, and many other things. Eigenvalues, eigenvectors are also being covered. So you can go to my playlist in quantum physics. You can go through those videos. I think it will be very easy for you to understand. The book then explores about the origin of Schrodinger equation, giving a little bit of history. Here you can see how beautifully this book has explained each and every component, which is imaginary, which is Planck's constant. Absolutely awesome. Then it goes into time dependent and time independent Schrodinger equation, because we already know that. Apart from that, the Bond rule and the Copenhagen interpretation is also covered. Quantum state, wave function and operators, Fourier theory and quantum wave packets, infinite rectangular potential wall, and so on. Now I will come to the last part, that is, what is my honest opinion about this book. Well, I can tell you this much, that this is the book to learn Schrodinger equation. There is no other book which I can tell you that is better than this book. So this is the book to learn Schrodinger equation, and most importantly, this book assumes nothing. No advanced mathematics, nothing else is required. You just need to concentrate, and if you want further, you can just go back to my videos or the other books which I've told. So it starts absolutely from ground zero level without assuming anything. These books make you prepare for everything that you need to know. It is very well arranged, and I would say it is the easiest, simplest, and one of the best books to learn. So having said that, this is the best book obviously to learn Schrodinger equation. What about the YouTube videos? If you're learning through videos, then what are the best YouTube videos which are available for Schrodinger equation? Coming up in the next part of the video, what are the best YouTube videos on this? The first I would say about this Physics Explained, this is absolutely great. As you can see, the time length is more than an hour, so it explains with utmost intricate details. Then you can go to Parth G. He is a very dynamic and a great maker of YouTube videos. You can see here, you can go to Schrodinger Equation Explained, and you can find it over here. This book is also very good. This is from Professor Dave, and he explains it very easily. Apart from these videos, I would also recommend this book of this video of Schrodinger equation by Professor M, and obviously the last and the best, that is Brian Greene's Your Daily Equation, part number 12, the Schrodinger equations, the core of quantum mechanics. All these videos, links are provided in the description box of this video, so you can just go ahead and check it. So that's it. I don't need to expand much of the videos. Thank you very much for watching this video. If you have liked, you can hit up the subscribe button and click on the bell icon to get all the notification from Physics for Students. This is my Gmail ID, and this is my other channel on General Theory of Relativity, and you can follow me on my Facebook, LinkedIn, Instagram, and Twitter account. I think that you have liked the video. I would wait for your comment. Most importantly, this is a great book and a great adventure to explore and understand the complex Schrodinger equation. Stay tuned for more interesting videos from Physics for Students, but till then, goodbye.